All right. So welcome to the CFM per November 2023 event, which is the title, which with the title Generative AI Transformation or Hype. This event is a part of a series of events on the economic and financial application of alternative data sponsored by Capital Fund Management, CFM, and the Program for Economic Research at Columbia University's Department of Economics. And before we start, I want to give Adam a minute just to explain, to talk a little bit about our joint initiative. And please, Adam, go ahead.
Thank you, Jose. Hello, everyone. CFM per Alternative Data Initiative has been launched because of how important alternative data has become in investing and economics. The joint initiative enables PhD students to use alternative data sets in their research projects and provides a platform for cross-collaboration between academics and investment professionals. While many of the alternative data sources are novel and previously unexplored, it is important to maintain the same high standards of academic rigor when examining their usefulness in explaining stock market and economic phenomena. Also, as a part of the CFM per Alternative Data Initiative, we periodically organize seminars on data sets and research that are timely, and today's edition focuses on application of AI. I'm excited to follow Markus' presentation and the ensuing panel discussion. Thank you, and back to you, Jose.
Thank you, Markus. Thank you, Adam. And I want to introduce Markus Leippold. In fact, he asked for no introduction because his introduction is part of his talk. But just to tell you that Markus is a top researcher in applications of AI, and he has, in particular, today he's going to talk about a theme he has contributed, which is about what can generative AI contribute to climate research. After Markus's talk, we're going to have two initial discussions that are going to talk very briefly for about 5 minutes. Laurent Lalou is the Chief Product Officer at CFM, and Marianne Farboudi is the John Gruber Development Professor at MIT Sloan School of Management. So, Markus, go ahead.
Well, thank you very much, Jose, for the introduction and providing me the opportunity to present here. Maybe just to manage expectations, this is not going to be a typical academic talk where you have a kind of a hypothesis and then present some formulas, very complicated formulas, and then throw in some tables where you have massaged the data so that it confesses to the original hypothesis. It's more or less kind of my experience that I made over the last couple of years in using something which is called artificial intelligence in the press, but essentially it's just big mathematical models to analyze in particular problems in sustainable finance. So as I said, I didn't want Jose to introduce myself because I did a small experiment over the weekend, and I asked GPT 3.5 to write the biography about myself. And of course, GPT 3.5 did it quite eloquently, but it made tons of mistakes. So first of all, I'm not that old. I'm old, but it told me that I was born in February 12, 1965. I'm 5 years older, and actually, as you will see, I was not born in Switzerland, so there was another mistake. Then it tells me that I have attended the University of Zurich and made my bachelor degree in economics. Absolutely wrong. It tells me that I did my PhD also at the University of Zurich. Again, completely wrong. But then something which I liked very much is that it tells me that I did groundbreaking work in the area of asset pricing and financial derivatives. Of course, this is absolutely flattening, but I'm a modest Swiss person, and definitely I would not classify my work as groundbreaking, but this is how generative AI models, these chatbots, are actually trained. They're super flattering, and they make you just feel good. So I moved on to a more and better model, GPT-4. And actually, GPT-4 got everything right. And there's a slight algorithmic difference between 3.5 and 4, in the sense that when you ask GPT-4 about a person, it does some information retrieval from the web directly. So it got almost everything right, and it even got made a reference to some very unimportant interview that I gave to some local news press, where I said that I was born in Birmingham, Alabama, and that I spent 3 months there, and then 3 years in Lyon, France. And it tells me that this is basically defining my international experience. And I wonder how it comes to this conclusion, because the only thing that I remember are probably the diapers that I was wearing in the US and in France, and nothing more. But it interprets that as international experience. Well, with this kind of short introduction about myself, well, I should probably briefly talk about myself. So I'm a professor in mathematical finance at the University of Zurich. I'm a professor in this field since 23 years now, and about 6-7 years ago, I got more interested in applying natural language processing to sustainable finance. And back in 2018, I had the privilege to join Google for 8 months as a full-time visiting researcher. And today I'm still a visiting researcher at Google DeepMind, working on large language models. But my experience from asking GPT to write my biography and the kind of disappointing results probably puts the quote that you put for the advertisement of this series in a nice perspective. And Charlie Munger, who actually will turn 100 years old in January, next January, he said that, I think old-fashioned intelligence works pretty well. And well, I don't know. I try to convince you now that he's not completely right. Although if you would think that success is defined in terms of money that you gain over your lifetime, then there's probably no argument against this quote. But whenever you need to apply intelligence, what you actually need is information. And where do you get this information from? Well, I think 2 students 25 years ago completely changed the way how we collect information. And these were actually the students who came up with this web page here, the Google web page, which 25 years ago had exactly this kind of look. And Google at that time was indexing 25 million web pages. Today, we have about 10 or even 100 of billions of web pages that we need to extract information from. And Google at that time, the mission was to organize the world's information and make it universally accessible and useful. But there is one problem with information. Information is cumulative. In the end, we are just drowning in information. We have so much information that it's really hard to identify the information that is actually useful for us and also decision relevant. So what about the situation where we would have tools, and you might call it artificial intelligence, that would allow us to process this information in a meaningful way? And my argument is that with generative AI, we would actually be able to build narratives around these meaningless pieces of information so that we can be informed to make decisions. And in order to get a little bit of a historical perspective, although in computer science, history is kind of a funny term, because history means, the old times was maybe 4 years ago. And for that reason, I want to go back 4 years in history, when the first models and groundbreaking models in natural language processing appeared. And these were the GPT and BERT models, because these were the first models that allowed us to understand text or words in the context. Before, it was really hard to extract meaning out of sentences, but with the new transformer technology, which is a certain type of network architecture, it was now possible to really identify the meaning of the words in its context. So these were the BERT models, and soon after, the models got even bigger and bigger. So on the left-hand side, you have the number of parameters, and probably Palm has 1 trillion parameters. There are no certified figures about that, but there was a huge increase in model size. But the architecture of the networks were basically the same. So the only thing that changed was the scale of the models, and also the number of words that you put into the models, that you feed into the models. So, for instance, a 13-year-old human would have seen by that time about not more than 100 million words. But these models, these big models that we have now, they have seen 1.5 trillion words, and they can digest all this information. So that's just massive. Of course, there is one question which is related to climate. So the energy use of these models is really big. And back in 2022, we were writing a paper that should hopefully, discipline researchers, especially in NLP, to keep track of their energy consumption. So the first part of my talk is really about this first generation of models, and we call them in computer science foundation models. So these are the BERT models and the early GPT models, GPT-1 and GPT-2. And I did a lot of research using the BERT model. And BERT model, which also are called artificial intelligence models, although they do not really look super intelligent, were used or developed at Google back in 2018. And I was exactly at the right time, at the right place. So I tried to use these models for financial research. And I did something which, as a financial mathematician, you would never, ever do. And I started to read regulatory documents. Everybody knows the 10K filings. And these are, as a financial mathematician, you do not touch these kind of documents because it's not that interesting. So why not use BERT to analyze all this huge amount of text? So back in 2019, we started to use the BERT algorithm to analyze climate risk disclosures in the 10K filings. Now you have to know that 10K filings, which are the regulatory filings that each company that is traded on a US exchange needs to file for at the SEC. And there's one item, the item 1A, in which the companies need to document or need to disclose their risk in a forward-looking manner. So what we did, we were looking at climate-related risks, transition risk on one hand, and physical risk on the other hand. And we try to understand whether companies that disclose these risks are actually punished in the market for credit default swaps. Because if they have a large exposure to these risks, our expectation was that these risks would materialize on the tails of the distribution for the companies. So not just in the equity premium, but in the tails, and we would capture these tails with credit default swaps, because they're essentially nothing else than put options very far out of the money. So we analyzed that, and we found that when you have these events like the Paris Agreement in 2015, where everybody is aware that governments will probably move on to impose CO2 taxes on the companies and therefore influence their financial well-being, that this will then eventually materialize in the CDS prices. And we saw that there was a huge positive effect on the transition risk component, and it was economically significant and also statistically significant. But 1 year after, there was this guy becoming president, and of course, the CDS prices went exactly in the other direction. And again, very significant and statistically significant and economically significant. For the sake of time, I'm going to skip this graph. So we have written a paper which was then published in the Journal of Financial Econometrics. But we were really motivated to dig deeper into natural language processing, because it seemed that these new models were actually opening up a whole new area or whole new possibilities to analyze data, textual data. And we know that, in financial markets, information is really crucial. Data is really crucial. And about 80% or even more of all the data that is available and relevant, 80% is unstructured data, which can be then analyzed with these kind of algorithms. And for that reason, we took the original BERT algorithm, and because I'm personally interested in climate and climate risk and sustainable finance, we pre-trained the whole algorithm so that it got an even better understanding of climate-related text. And for that reason, we created an algorithm which we then christened Climate BERT. It was trained on a huge amount of climate-related text. And with this Climate BERT model, we were then able to analyze tons of different questions, which all resulted in a lot of different papers. So one example is that we analyzed the corporate communication in annual reports. We wanted to understand, when they talk about climate risks, what do they really talk about climate risk? Is it about governance issues, about strategy issues, risk management, or even metrics and targets? And as you can imagine, companies, they do not really like to talk about metrics and targets because this is very, very specific. So we found that by analyzing huge amount of data, or 15,000 annual reports, we found that companies really do cherry picking on what they disclose. They talk a lot about governance and strategy because this is a lot of boilerplate language which does not really have which does not really provide decision useful information for financial markets. So then we created a further algorithm that can identify precisely environmental claims by companies. So we can scan huge amount of data, and we can really extract from this data all the environmental claims that companies are making. And of course, this attracted a lot of interest from regulators in particular, because they want to screen this kind of environmental claims. But we also were approached by law firms because they want to screen for potential clients when there is some climate litigation in the future. We looked at whether when companies make claims, whether these commitments actually have an impact on reality. So what we created in a paper was we created a cheap talk index where we analyzed commitments of companies in annual reports, because these are audited documents, and the ratio of non-specific commitments over all commitments, again, identified by the algorithm, is then what we call the cheap talk index, or the CTI. And the CTI actually has predictive power on the future emissions of companies. Companies, the big cheap talkers, are actually those companies who have the highest emission increase in the future. And moreover, the cheap talkers are those companies which will have in the future environmental incidents, negative news press coverage, and environmental incidents that are then imposing some reputation risk and hence also some financial risk. In another paper, we wanted to look beyond patents. So we wanted to see, is green innovation, but not just green innovation, but also green technology adoption by companies priced in financial markets? And I will come back on another slide on how we achieve this goal, because that involved then already the second generation of foundation models, which is generative AI. And I have a separate slide on that. And then we did other stuff like analyzing net zero commitments of companies, because this is now also very important, so that companies are actually committing to specific net zero commitments, and we can use these net zero commitments to analyze the credibility of their commitments and of their transition plans. And the next big thing in disclosure is not just climate disclosure, but also nature-related disclosures. And we just have finished a new paper and an algorithm that analyzes this nature disclosures. Obviously, as you can imagine, just to think, we are academics, or probably not everybody in the audience, but we want to write papers. This is important, but we also want to have an impact in the real world, because especially in climate finance, I think this is very important, so that we do not just try to get into the top journals, but also have an impact. And my work, I'm very happy about that, also was picked up by the Financial Times. So Gillian Tett was writing about Climate Bird. Then I was able to give a TEDx talk early this year. Forbes magazine was writing about 4 different AI-based techniques that should drive radical ESG transparency. One was Clarity AI, which is a startup. The other one is Greenwatch AI, which is an NGO startup kind of organization. And then there were 2 algorithms mentioned, Climate Bird and Chat-GPT, which are open sourced algorithms, which come from my team that we provide to the public. So I was very pleased to see our tools having some impact in also in industry. So let me briefly talk about the second generation of foundation models, because the Chat-GPT that was mentioned in the Forbes magazine article is basically one of these newer models that we created early this year. So the first time I was using generative AI for financial research is actually when we were using, or when we were analyzing green innovation and green technology adaptation in financial markets and how it is priced in financial markets. What we did is the following. So everybody knows that green patent data is a valuable source of information. But one problem with green patent data is the following: when you want to analyze the impact for financial markets, investors probably not pay too much attention to these patterns. They pay much more attention to, for instance, what the CEOs tell you in earning calls. So we wanted to bridge this gap between green patterns and earning calls. Now, green patterns, they have a very technical language. So we took, at that time, GPT-3. We fed in the green pattern abstracts, and we told GPT-3 to summarize the green patent abstracts in a language that is understandable to the layman, non-technical language. Just tell me what this green patent abstract or this green patent is all about, but in a language that I, as a financial analyst, can also understand. Then in the next step, we use these sentences generated by GPT-3, and we fed it into a climate bird classifier so that we can analyze the different categories of green innovation, whether it's energy, transportation, production, building, adaptation, environment. And with this classifier, we were then able to analyze the attention on green innovation and adaptation in the earning call transcripts. What we then found is basically in line with previous literature that only looked at green patents, that there is a negative green innovation premium. But we also detected that you can differentiate between green attention in earning calls, expected attention, and unexpected attention. And this unexpected attention had actually quite a big driver, because what we saw is that this green risk score actually serves as a nice hedging instrument when you have shocks in the climate policy. And probably in the next US election, we will also have kind of a climate shock, unfortunately. But for instance, when we analyzed the Russian-Ukraine war, we saw that there is a positive shock. So you could use this kind of portfolio as a hedging instrument against these shocks. When there was the IRA announcement, there was also kind of a positive cumulative return that you were able to generate by building this hedge portfolio. One problem, however, is when you use this generative AI, and as you have seen when I asked GPT-3 to provide a biography of myself, is that these models have the big problem that they hallucinate. And they hallucinate in a way that is, as you have seen, very flattering and makes you feel very positive, because that's how they are trained. And the question was 4, 5, 6 months ago, how can you ground these models so that they stay to the truth or the ground truth that basically the user defines? And we were able to do that with Chat-IPCC. So what is Chat-IPCC? Everybody knows the IPCC report. So we forced the AI tool to read all the IPCC reports. And when you ask questions to the tool just gives you an answer back from the IPCC reports and does not hallucinate or add anything else. Unfortunately, we cannot call that Chat-IPCC anymore, because 2 days after we published and made a website called chatclimate.ai out of this tool, I got an email from the IPCC communication office telling me, hey, don't call this Chat-IPCC because we are not endorsing this kind of strange, opaque language models. And therefore, we renamed it or rebranded it to Chat Climate. The positive side effect of this intervention, by the communication office of the IPCC was that I have now 2 projects with the United Nations using large language models. So from that side, I was very pleased that they were upset. And of course, I was also upset that they forced me to rename it. So what is Chat Climate? Basically, you can ask a question, but you can also think about applying this kind of technology, which is called retrieval augmented generation, to financial problems or to financial documents. But here we were interested in climate relevant documents like the IPCC reports, because again, the IPCC reports are the most authoritative and commonly agreed upon documents. And although I work in climate finance and sustainable finance, I have never ever read a IPCC report. Wouldn't it be great if you have a tool where you can ask questions and you get exactly the answer that an expert who has read these 10,000 pages of IPCC reports, and it gives you an answer, and it gives you also the references to the IPCC report, to the chapters. And if you don't trust the tool, you can go back and check whether indeed the chapter that is referenced talks about the information that is provided by the tool. So that was also very exciting, and we were writing a paper about chat climate, and hopefully in the coming week or 2 it will be published in Nature Communications, Earth and Environment. But the Chat IPCC tool is basically just a Q&A system. So we wanted to go one step further, and that's how we came up with Chat Report. Now, today I was just giving another talk because I'm co-organizing a hackathon between Google and MSCI. And rating agencies, they have the following problem. They need to read regulatory frameworks, then they need to read corporate sustainability reports, and then they need to assess whether these corporate sustainability reports really meet the criteria that are laid out in this regulatory framework. And then they have to make a scoring of the corporate sustainability report. This is what a junior analyst typically does. So take the TCFD, for instance, the Task Force for Climate-Related Financial Disclosure. The framework, you have 11 questions. You need to answer in your corporate sustainability report all these 11 questions in a certain way. So the qualitative assessment is also laid out in the TCFD recommendations. Now you take a Sony report, which is usually around 500 pages, at least 3 years ago, and you have to assess this report. It's a lot of work. So we created Chat Report. It's a system that we developed, a prompting system, and there's a large language model or generative AI model behind it. You have these 11 questions, like, for instance, how does the company board oversee climate-related risks and opportunities? And then you have more questions. And in the report, for each question, you have the description of what a company ideally should report when answering these questions. And you can throw this information into the language model, and you get an assessment. For instance, well, I wanted to hide the company name here, but I forgot it. JP Chase, for instance, plans to disclose additional detail on its efforts to integrate climate risk into its firm-wide risk management, and so on and so forth. So that's the answer taken out of the corporate sustainability report of JP Morgan. And then you get an analysis, and you get a score from 0 to 100. Of course, 0 is not very good. So JP Morgan here scores with a 20, and you can eventually aggregate that. and get a final score. So what I did then over a weekend, I analyzed 11,000 corporate sustainability reports with this tool. So for each corporate sustainability report, I then get kind of a short executive summary with a score. And that's just amazing, right? So it completely substitutes. Of course, you need to have human controls, but it completely substitutes the work of a junior analyst at a rating agency. And you can do that at scale, right? So I did that on my machine, on a Google Colab, just in a few hours. 10,000 or 11,000 reports. And try to imagine how much that would cost the company if there is a junior analyst who goes through 11,000 corporate sustainability reports, always keeps in mind the TCFD questions that need to be answered in each of these reports, which are sometimes 200 or 300 pages long, and then needs to make an assessment of that, and then needs to write it up in terms of an executive summary. And then you can, let's say for a financial research project, it could be interesting to then look at the TCFD conformity score. So how well do companies report according to the TCFD guidelines over the time? Here I plot, the TCFD conformity score of the year 2016 and 2021, and you see this right shift. So therefore, companies seem to adopt to the TCFD guidelines. And then you can potentially compare that to emissions or pollution indicators or whatever indicators and see whether companies are actually walking their talk or whether they just talk. The TCFD, of course, is just one example. There are other examples that we are now working on. The TNFD approached us whether we would help them to build their chat tool for TNFD, the Task Force for Nature-Related Financial Disclosures. Last week, we basically wrote our latest paper on nature-related disclosures, where we trained a BERT model to identify nature-related disclosures. And there is, as you can see here, when you look at the performance scores of our algorithm, it basically perfectly identifies biodiversity, nature, forest, and water discussions in these earning calls that we analyzed. Now, maybe you know the paper, which is as the not so modest title, Biodiversity Risk, by some colleagues in the US. And they use still keyword-based approaches. This is a little bit the problem. I would have to honestly say that it's not really perfect, that the finance research is lagging behind a little bit the progress that is made in computer science. So these keyword-based approaches, they're really suboptimal, and often finance papers, they lack a comparison of the performance of identification. So when we use in our data set the keyword-based approach of Giglio and others from NYU, it's really suboptimal. So you get a recall of almost slightly above 50%, which means that once you identify a positive sentence, it's basically throwing a dice whether this is a false positive or a true positive. So, finance research would be well advised if they would further look into the state-of-the-art models that are out there in computer science. So my conclusion is basically the following. So I think that the initial quote that I was showing is right. We need also old intelligence, but this human intelligence needs information. And of course, we have the mission of Google, which is to organize the world's information, which is absolutely great. But we need to adjust a little bit this slogan or this vision, because the information that we have these days is so huge that we need to make sure that we can organize the relevant information and make it accessible and decision useful. And for this kind of task, generative AI can actually be a wonderful tool to achieve this goal. And this is at least my experience that I made and that I'm currently making with much more additional projects that I'm engaged, also with policy institutions like the United Nations, where decision useful information is particularly important. So I think that my time is up, Swiss timing. So thanks a lot for providing me the opportunity to share my experience that I made and over the last couple of years. So basically what I have presented here is like a mix of something like 30 papers that me and my research team have written in the area of natural language processing and sustainable finance over the last 3 years. So thank you very much.
Thank you very much, Markus. This was a wonderful talk, and as you said, a wonderful timing too. So I turn now to Laurent Lalou, who is the Chief Product Officer of CFM. They will make a short intervention.
Thank you, José, and I would like to thank Markus for a very insightful presentation. I think it resonated a lot with what we're experiencing as an asset manager at CFM, doing a lot of research using this kind of tool. And I really appreciated the fact that you've tried to show how to use this tool from a pragmatic and practical angle in a very important topic, which is sustainability and climate, where it's totally dominated by unstructured data, and you've really shown that leveraging this latest computer science technology allows you to do something which otherwise would have been impossible by purely relying on existing structured databases. But maybe another point I find interesting is that with such kind of typical with you have these new technologies, people tend always to overestimate short-term benefits. So you get big splash in the news about this is AI, this is the latest creation of human being, blah, blah, blah. But we tend to underestimate actually the real impact of Gen AI on the long term. And in particularly, we're seeing that in finance and from our side in asset management, that these tools are highly evolved statistical objects which are able to extract information and data in an unconventional way, and which help us effectively dig for information where it would have been totally impossible to do that previously. Obviously, this is important for risk management. This is important potentially for alpha generation. But I would like to stress also that these tools have more menial productivity impact as well, in particularly just the ability to code faster and better is definitely something we are experiencing on a day-to-day basis thanks to these tools, which is really something important and which might have a much deeper impact in all kinds of industries. And finally, I would like to stress that we are not the only one, obviously, using Gen AI. I think the banks have a lot of initiative around that. Having internal chatbots or help tool which help answering clients' question is definitely something which is very useful. Processing a lot of internal reports, internal research, and extracting the relevant information out of text is something that we see a lot in finance. and including also data provider. I mean, news data provider are able to use this technology and training their own LLM on their own data set to help internal processing or of very standard information to help actually people focus on the important part of what we do. So all in all, thank you again, Markus. I think it's a very important tool which is being brought forward in financial analysis in particular, but which can have a lot of impact across many industry going forward, and we should really have a keen eye about where it goes and what it helps us to do with a very open mind about its application going forward.
Thank you, Laurent. And I would like to ask Marian Farboudi to do also a short intervention to start a debate going. Thank you. Is Marian in? Maybe she had a problem. Okay, if Marian didn't make it, so we can go on and continue. So let me start with a general question. I think it touches on things that Laurent talked about, which has to do with what we're going to use these tools for. And you go back to what happened with the internet. The internet was basically invented to share computer resources. Now, that eventually became a business. Amazon made a business out of that, and Google and others copied. But it took many, many years, decades for that to happen. In the meantime, email came in. I think that was one of the first things that monetized the internet. Then you had, of course, Markus's employee, Google, monetized search in a heavy way, and then social media. So I would like to ask Markus initially to kind of speculate, where do you think this is going? What are the things that people should be thinking about in terms of applying, where AI is going to be used in the long term, as Laurent said?
Well, that's obviously a very good question. And, I think one has to differentiate a little bit, how the development will be for, the day-to-day user of generative AI versus the business user. And the day-to-day use will definitely be to improve the search experience, right? So when you do Google search, at least now it got better, right? Since 2019, you also had the BERT algorithm incorporated into the search so that your search got understood in context. But before, when you did the search, you get kind of linear results, and these results are then somehow, kind of, you never know how the ranking actually emerged. So when you were, let's say, if you were a climate denier, and you would search climate change is a hoax, you would get confirmation, right? Because on top you will have Donald Trump talking about climate change and others. So that puts, of course, the big tech companies in a very awkward position, because they can steer what is being explained and how it's going to be explained to those who make a search query. And this can be very powerful. And at this time, what lacks in the whole large language model literature, at least in part, because we wrote a paper with Google DeepMind on this topic, is how do you evaluate the answer of a large language model? So how can we know whether it's good? I mean, there's, of course, the grounding, whether it's truthful or not, but how can we analyze the presentational dimension and the epistemological dimension of an answer. So this is more like from the user specific kind of viewpoint. But then for companies, no, these models, they would really change the way people work. And it's probably comparable. I think McKinsey compares this to the blue collar industrialization, the impact of industrialization on the blue collar workers. But now it's not the blue collar workers, but the white collar workers, right? So I brought this example of the junior analyst. So basically, you can have already now a large language model to replace some of the work of these junior analysts, and they can have more time to think more about things where human intelligence is more needed, and where artificial intelligence, I don't like this word too much, can actually replace, not yet replace humans. And then, of course, you know, a big step going forward is definitely, you know, connect these large language models with multimodality, where you would, for instance, analyze satellite data. You ask questions to satellite data. There's one project I'm involved in with the World Meteorological Organization, where we try to link complicated climate models with potential output of satellite data with language models, so that even somebody who does not know anything about climate change will get access in an understandable way to the complex output of these models. So I think if there's not too much regulation coming up, this is what the development that we will definitely see in the near future. And it goes so quickly. You mentioned that it took years in the old days, and now it's, you know, we have weekly reading groups at Google DeepMind where we present the newest research. And if I have Corona for 1 week and I have to wait 2 weeks in order to present the paper that I was supposed to present 2 weeks earlier, it's already old. There's so much research going on, and what is new this month will be already old next month. So sometimes I wish back the old economic, the finance papers where you fight for 3 years until it gets published. But this is not happening in computer science.
And let me mention something, do a little bit of advertising. I'm one of the editors of PNAS. Of course, I take care of economics, and we do a much faster job. So, Laurent, do you want to add something to this?
Yeah, I think that Markus knows much better than me what's happening in search, and definitely that's what as individual will be experiencing the faster impact of LLM is how to search better the internet, or even as a researcher, you probably also experienced that, Jose, is that if you want to dig into a new area or a new topic, and you want to learn about a new subdomain in your field, using an LLM to ask you, could you tell me about this domain, and providing you with a basic look and some also important references is definitely useful, provided that they don't give you some hallucination along the way, which is always the danger of this tools. I think that one of the difficulties is that an LLM will always provide you with an answer and never be able at this stage to tell you, I don't know, or rephrase the question, which I find is the biggest issue with the technology at this stage. And that's why you need to have someone look at the answer, analyze, rephrase the question, and make it more useful by interacting better with the system. So it requires a lot of know-how.
Yes, I agree with what both Markus and Laurent said about that. It looks like improving search seems to be the kind of a most immediate thing. But remember, social media came up, nobody who was thinking about internet thought about social media. So there could be innovations also that we have no idea what they would be, right? And I was asking Markus also to speculate on that, because I imagine people in a place like Google are thinking about that. They're thinking about where should we go? You know, what kind of thing could we do to make things, you know, to use this kind of tools in a very efficient way. Adam, do you want to ask a question right now?
Hi. Yes. So, we have seen in the past few days, few weeks, that there are some very heated debates around whether the AI, Gen AI, is safe. And I was curious, what are your thoughts on this? What are the risks? What are the dangers that AI poses, and how we can safely develop that technology?
Well, I'm part-time working for a big tech company, so I have to be very optimistic about Gen AI, of course. But the biggest risk is, of course, misinformation. So it's very easy to, generate misinformation that looks really great. And one big question is, how can you do the fact checking? But at the same time, I also have to say that fact checking has become much easier. So I'm currently working on a project at university where we have we call it Judge Climate, and I hope to have the paper out maybe in 2 weeks. And we can analyze all the claims that, for instance, climatefeedback.org, which are about 170 claims, or skepticalscience.org puts online and demystifies by having a climate scientist writing a short half-pager, or on climate feedback, even 3 pages or so. And you can do that now in seconds by, even having debate about it. So you can have language models debating on certain topics, which is kind of a like connecting to Marvin Minsky's idea of the society of minds, where, like in the ancient Greek times, you have a debate to reach the truth. And here, what we implemented is like debating advocates of certain fields that start debating about a claim. So there are also a lot of potential on the other side, on the positive side as well, to counteract the dangers of generative AI. And of course, one big problem, and I have no idea how one can solve this, is the resources that are needed to build these models. But on the other hand, I think that especially for practical use, downscaling models is something very useful and very practical. And this is what I also do in my own research in finance. Is in the end, we don't use the big models. Maybe we use it to annotate data. But in the end, you have a small model that you can upload on Hugging Face, and everybody can use it, and you get really decent results for the task at hand. But of course, there's a lot of problems that we need to find answers to, and I don't have answers to all the problems. So I just try to contribute my share to solving these problems, especially in the fact-checking domain, and adjust the fact-checking tools also with generative AI so that they become more powerful.
Thank you, Markus. In fact, since Adam raised this point, an associated point is what went up with the AI company that, the CEO was fired and so on. Do you have any insights on what was going on there in terms of, what are the differences? There were two differences, or just a common question of how the board looks at the CEO and vice versa?
No, I don't have. I definitely do not have any insights there, and probably I'm glad that I do not have any insights there. But maybe I can give you a short anecdote, completely different context, about the misuse of generative AI. So a good friend of mine, family that lives nearby. So they have 2 kids, 12 and 16 years old. And they, teenagers, and they make a lot of troubles, like teenagers usually do. So they were given the task to write a letter to the mother why she's doing a good job. And then the letter was really great, but it was obvious that it was generated by GPT or Chat-GPT. So the parents were really upset about the kids using GPT to write something which they should have made some thinking about some obvious reasons. And this is another danger, right? So we stop thinking. We often use, and even if I talk to people from the United Nations, policymakers, so they often, to be quicker, they just open up Chat-GPT. They write something that they want to improve, and then they get a suggestion from GPT, and without too much thinking, then they send this out. So it will eventually have an impact on a lot of things in our daily life. So this is another danger. So that's the only anecdote that I can give. I cannot give any information to the anecdote of OpenAI and all this hick-hack.
Okay, if people from the audience want to ask a question, they should send me a name. I don't think it's going to work just to have hands up, because there are just too many people for me to be able to find, everybody in the screen. So I would prefer to get in the chat a private message to me asking whether, a question. They could type the question and so on, and I'll reproduce the question. Before I let that system start, I would like to ask one more thing to Markus, which is this. I think you guys did a terrific job linking companies' promises to do certain things with whether or not they achieved it, which is what which seems to be what you're saying there. But there is this question, there's a lot of leakage on climate stuff, on the sense that maybe some company does something, but somebody else is going to go back and do the same thing, the bad thing in a different place, or a competitor and so on. Have you guys have a look at that? How much leakage there is? How much the actions of the companies really result in improvement on the climate question?
So the only metric that we were so far able to use was, emissions. And one further avenue of research is to start looking into geospatial data and link the talk to what we actually observe. And so I've currently a research project that I try to formulate to get some funding for. And that is then trying really to connect this information from satellite data. You need to have asset level data for the companies. You need to have information on the supply chain, and only then you can really nail down the company's action, whether they live up to their promises. But this is the grand goal that I have in my next 2-3 years of research.
Yeah, in particular, I think that supply chain is a very important thing, right? Because you can, just like some companies hire companies, then hire slave labor, companies can hire companies that then do the pollution for them, right?
Yeah, exactly.
So that's a very, very, I think that's a great economic problem to look at. Somebody asked the following question. How could you effectively impact this generative AI for developing economies in general? How do you think those things can help developing economies?
Well, that's a good question.
This is being mainly used, of course, in advanced economies, right?
Yeah. So I can only answer that from one aspect, and it's probably not the one you were looking for. But one goal of the United Nations is to have in place an early warning system for all, which means that everybody should have access to relevant climate information in real time. And I'm part of this sub-working group at the World Meteorological Organization. And there, we have special focus on the global south and how it can help them to provide this information system. So obviously that has nothing to do with the economy, but more like for the daily life of these people that need this information also to improve their understanding of climate change. And that's the only answer I can give in this direction.
Yeah, I mean, the question of how disaster would occur, that's, and also to pay attention to disasters as they form, right? Is that what you're talking about?
Yeah, exactly.
Yeah, that would also be useful for somebody. It's also for an investor too, right?
Obviously, yes.
Provided they have the right information about where the plants are and so on.
Yeah, but yeah, of course, that's yeah, but that's not the intention of the World Meteorological Organization.
I understand, but it's
no, it just
that may interest some of our audience too.
Yeah.
So how there's a lot of work right now in trying to understand what places are in long run risk, what sites in the world, for instance, are likely to be more affected by the rise in sea level and so on. Some people have been looking at the companies that are exposed to that because of their facilities or the kind of business they're into. But there's also the question of short term, which I suspect that's what you're talking about, right?
Yeah, and short term also, like Google DeepMind just had a paper out in Science, and it was also mentioned in the Financial Times. So the weather forecast, short-term weather forecast model is now obviously the best weather forecast model, and it predicts already compared to the existing top models that predict hurricanes in 6 days in advance. It can now predict hurricanes landfall 9 days ahead. So you have 3 additional days. And obviously, as an investor, that could be kind of important information.
Right. It's a classical problem the great mathematician John von Neumann thought about very hard, right? Why is it inherently hard to predict weather. And
it's kind of interesting that this weather model is totally ignorant of physical laws. So compared to the big weather models that build on physics and physical laws, this model only takes past data. So the next step now would be, of course, to combine a little bit of physical laws with this massive amount of data that is put into these huge neural networks to even further improve the weather prediction.
So one more question. You know, we know, for instance, something which I think is basically useless, like crypto, consumes a lot of energy. Do you have any? And I'm not comparing the two because I think AI is much more useful, much more able to produce stuff that's valuable for humanity. But how much energy do you think is being consumed right now in AI?
You know, when
there are estimates?
There are definitely estimates, but I'm not too aware of. So what we usually do, you know, in a paper that was published at EMNLP, which is one of the leading NLP conferences, we were proposing kind of a model card that takes into account the electricity usage of the experiments and also states what was the energy mix by which that was produced. Was it renewable energy or something else? I guess that the energy used is just huge. For instance, I briefly talked about the BERT model. So pre-training the BERT model takes, you know, eats up as much energy as a flight to New York. So this is about the comparison. And here we were talking about the BERT model, and of course the BERT model was just 300 something million parameters, and the current models are much bigger by a magnitude.
Mm-hmm. Yeah, but I mean, flight to New York is relatively little compared with how much is used for, you know, for Bitcoins, right?
Definitely, yes.
Those are different orders of magnitude. You know, you talk about cities' consumption per day, you know, equal to cities' consumption.
I think it depends a little bit. Like if you look at Ethereum, Ether, then, you know, the energy consumption is very low. But Bitcoin, of course, is still super large. But yeah.
So maybe Laurent would comment a little bit about other applications. Markus did this very good application on climate finance, very important one. I was wondering if Laurent could tell us from the practical point of view, people who are actually using this stuff, what kind of things are you thinking about without telling us any of CFM's secrets?
Sure, thanks, Jose. So, well, definitely, like Markus illustrated, when you have text or transcript, you can try using this technology to extract some structure out of unstructured data and then do your, you know, usual quant job once you have the structured data. So that's something which is definitely where we're thinking a lot. We're trying to use that a lot. Maybe something which is less obvious, but also definitely very useful is to clean data. To give you a basic example, you might have a data provider which will tell you that this refers to the company IBM. Another one might tell you it's International BizMash. Another one will have International Business Machine Corporation, blah, blah, blah. And they might each have different referential with different typo or sub strategies to shorten the name. and trying to match across this database the same identifier to build your own differential can be a tedious task. And the LLMs are typically extremely useful in doing that, because they can grasp this information and help you do that faster. So cleaning data is not an obvious idea, but using that is definitely something very useful, which you could use also in academia to try to make more sense with a lot of databases that you want to dig into.
Yeah, economizing on graduate students.
Exactly.
On graduate student time, yeah. No, this is yeah, I can understand it's also very important from a business point of view. You know, years ago, Alan Blinder, who had been at the council for the Clinton presidency, at that time he was my colleague at Princeton, and he told me there was a recession during the Clinton government that I only learned about a couple of years later. You know, so there's also this fact that data is produced and then new data is produced, and the question is how to harmonize what people knew at the time with what people are doing are know now, and that's also a task that maybe AI could help a lot, right? To find, you know, whatever the data, how data looked at different times and how it evolved. You know, not the data itself, but what was reported about data. So that could be also an important question to go through. And so maybe Markus would also comment. We talked about, you know, you talked about your work on climate. What are the other things that you know about researchers which are doing things in finance using AI that you think is good? Not the keyword kind of stuff, but other stuff.
So your question is what kind of interesting
what
stuff
are people doing using AI in finance in addition? You focus rightly on the climate things, which are very important, but there are other questions that I think you must be aware or you yourself worked on.
Yeah, I mean, the obvious kind of application is usually sentiment analysis, but people have been doing that already quite some time, and I don't know whether you really get a lot of insights out of that. Something else which I started to work on is how so we downloaded 10,000 articles from the top finance journals, and we plugged that into a knowledge graph. So a knowledge graph allows you to connect concepts and also think about causality, right? Because a language model is a statistical model of words. It doesn't know anything about causality. We might think that it knows something about causality, but you can then force the model to think about causality and also about concepts which are semantically not close, because language models are usually thinking about close concepts, at least in semantic space. And we created something which we call Professor X. We don't know yet whether we will write it up, but it's kind of interesting to, you know, have a conversation with a professor who has read 10,000 articles and remembers all the context of these articles. And I think this would help researchers to speed up also their research process and think about new creative ideas that you can look at. So I think there's definitely some progress that will go into this direction, in addition to, you know, this classical AI applications like sentiment analysis or yeah. So
Yeah, causality is a very important question, climate science too, because since we can't experiment very much, a lot of the climate science points out to correlations, which are important to look at. But if you want to intervene, I've been doing some work on forests, on the Amazon forest in particular, where you do want to intervene, then you really have to think about causal effects, because you have to really understand why is it that when certain regions are deforested, why do they have a big effect in other regions? And in other cases, that doesn't happen so much, you know? So you can look at the time series, but that's not very helpful. There's not enough there. So you really have to start thinking about causality in a serious way.
Yeah, that's actually an interesting application. And also because we just recently had our intern a conference at Google DeepMind Sustainability, and they created a model. It's called Forestcast, where they try to forecast deforestation, because this is a very important, obviously, a very important topic. Try to identify regions that might be deforested before deforestation actually happens, and so that you can intervene or a political process can be put in place.
Yeah, you're correct. That will be very important. But there's also the question then when you deforest an area, what other areas become a poorer forest? That's a question that has been looked at, for instance. And that's a question which, again, it's a question of causality, because there's a lot of correlation between the different areas, and you have to try to really isolate a causal mechanism to do something like this. It's not very different in many questions in finance, of course, where you find correlations which may not be very useful until you understand the causal mechanism that creates that correlation. You know, it's supposed to just observe that those things go up and down together or anything like that. Well, I don't have any open questions at this point. I was wondering if Adam wants to make a comment.
Yes. Well, I'd like to thank you, Markus, for a very nice presentation, and thank you, Jose and Laurent, for that discussion. You know, I guess at the heart of hearts, you know, the question is, what is the most efficient way of making sense of data? And the old time-tested approach is to use the human brain, but we're transitioning into this a little bit uncharted territory of using full machine-based modeling, and that can potentially unleash enormous gains in productivity throughout the economy and science and other source of human activity. So it's a fascinating subject.
Great. I want to thank you, Markus, and all of you who attended, and again thank CFM for the cooperation they have with Columbia. Thank you very much.
Thanks a lot.
Thank you, everyone.
Thanks a lot for having me. Thanks.